Now that we have had a look at the sine rule in the last couple of videos, there is another rule that goes along with it, the cosine rule. So when we have this triangle, which again I've labeled the corners A, B, and C, so that's what how we're gonna refer to each of these angles. And then opposite each one of those angles, we have the sides that are labeled with lowercase a, b, and c. And we're going to, the same way as back with the sine rule, this time we're again going to start by seeing what happens if we draw the perpendicular height like that. Now, previously, with the sine rule, we used this height and we used the sine of this angle to see what happens when we to see what we get with the height. This time we're going to do the same thing, but we're going to use the cosine of that angle. So if I have this angle here, which would be angle C, the cosine of that angle is going to involve the cosine is the adjacent over the hypotenuse. So the adjacent here is actually this side length here, this bit of this triangle, which is part of A, but we don't know exactly how much it is. So we're going to label that, because it's an unknown, this side length here of the triangle, that bit there, we're going to label that X. And if that is X, then this chunk over here would be A minus X, because this whole thing is A, and this bit here is A minus X, because it's A take away that X bit. So now, I've got this angle, I've got this perpendicular height, and I've split up my A side of the triangle into X and A take X. We're going to use two tools in this as we develop this rule. One is the cosine of this angle. So let's work out what the cosine of that angle would be. Cos theta equals the adjacent over the hypotenuse, so cos of C equals the adjacent, which is X, over the hypotenuse, which is B. And I'm going to rearrange that to get it in terms of X. So if I multiply both sides of that equation by B, then I get that B times cos of C equals X, or I'll just write that as X equals B cos C. So that's one thing that I can do looking at this triangle. The other thing is I can use a tool that we're all very familiar with, and that's Pythagoras. So I've got this X equals B cos C, and we're going to come back to that later. But before we come back to, so I'm just going to put a box around that so that we can come back to it. Before we come back to it though, let's see what we can do with Pythagoras. So we've got two right-angled triangles here. Let's look at the one on the left-hand side first. With this triangle, we're going to get that x squared plus h squared equals b squared. And I'm going to put that in terms of h squared. So I get that h squared equals b squared, take x squared. Now let's look at this triangle on the right-hand side. We have that a minus x squared, because a minus x is this side length, so I've had to put it in brackets and square the whole thing, plus h squared equals c squared. And again, to rearrange, to put it in terms of h squared, I'm going to get h squared equals c squared, take a take x squared, which I'm going to write as a take x multiplied by a take x. And the reason I've done that is so that I can easily expand those brackets to multiply it out. So we're going to get h squared equals c squared minus a squared minus 2ax plus x squared. Now, if you are not sure what I've done to get from this line to that line, then I recommend that you spend a couple of minutes expanding those brackets yourself, and you'll see you get to this result. Now let's just write that by multiplying everything by that negative out the front so that we can get rid of the brackets. H squared equals c squared minus a squared plus 2ax plus minus x squared. Okay, so we've got three results here. We've got that x equals b cos c, we've got h squared equals b squared take x squared, and we've got this as well. Now let's see what we can do with all this. The first thing we're going to do is we're going to take each of those two results over there, and the same way as back with the sine rule, we could get rid of the h squared by saying this equals h squared and this equals h squared. So these two must equal each other. We're going to do the same thing here. So I'm just going to write that on a new piece of paper. So our result is that b squared take x squared equals this whole thing. C squared take a squared plus 2ax take x squared. Now you can see that we have a take x squared, a negative x squared, on both sides of the equation there. So we can get rid of those. Those are going to cancel with each other. And we're going to be left with b squared equals c squared take a squared plus 2ax. Now, we don't want that x in there either, because we want a result that only deals with these a's, b's, and c's that we had in our original triangle. So we want to get rid of that x, and the way we're going to do that is by using this result over here. If x equals b cos c, then we can take this and substitute it into the equation for x. So let's do that. We're going to get b squared equals c squared take a squared plus 2a, and instead of x we're going to get b cos c. Now, just to make it easier with the positives and negatives, and so that it's just in an easier form to remember and to use, and this is now getting to the form that this formula is written in on your data sheet, we're going to try and get everything away from that c squared. So let's add a squared to both sides. So we're going to move that over to the other side by adding a squared to both sides. We get that a squared plus b squared would equal this. And then we're going to minus this from both sides. So we're going to take this whole thing over to the other side by minusing it from both sides. So that becomes minus 2ab cos c, and that whole thing equals c squared. So we get our important result, which is that if I have any triangle with a, b, and c as the side lengths and the angles like that, then I know that c squared, that's lowercase c for the side length, equals a squared plus b squared minus 2 times a times b times the cosine of c. And that is the cosine rule.